Hello, everybody, and Happy New Year, and welcome to the first 2025 Virtual Planetarium with Pete Lawrence and myself, Paul Abel. And we will start, as has now become the long-established tradition, with the inner planets and work our way out. So, Mercury. Let's start with Mercury. It's a morning planet, best at the start of January, but it is low in the dawn twilight, shining around magnitude minus 0.3, but in a twilight sky, that's not that bright, really. Visible 40 minutes before sunrise, but not optimal. And by January 9th, it's really heading back towards the sun.
I think the inner solar system is better represented by its outer neighbour, which is Venus,
yes,
which is going to be absolutely splendid during January. It reaches its greatest eastern elongation on the 10th of January, separated from the Sun by 47.2 degrees. And it sets 4.5 hours after sunset, which allows you to see Venus against a dark sky. Now that looks really impressive, but actually from an observing point of view, it's not so good, is it?
No, you're absolutely right, Pete. And just to say, we're recording this in mid-November, and I'm already now noticing Venus creeping higher in the sky. So we know it's going to be good January. But as you rightly say, it is the worst time to look at it. So if you've got a new telescope for Christmas and you're planning on waiting till the sky's very dark to look at Venus, that's absolutely the wrong thing to do. Instead, wait till you can pick it up in the evening twilight, because the glare from Venus's clouds is so brilliant, it makes it very difficult to look at it. But if you look at it in the evening sky when it's not too dark, the glare will be greatly reduced and you should be able to see the phase of Venus. So it is quite an impressive sight.
And as you go past mid-month, the phase will start to show a very definite crescent, which is my favourite time for looking at Venus. It's a beautiful crescent when it starts getting thinner and thinner, and the planet appears to get larger and larger. Its apparent diameter increases to about 1 arc minute when it gets at its closest point to the sun. So that's pretty big. In fact, that's on the threshold of naked eye visibility.
Yes. By threshold of naked eye visibility, you mean being able to see if it's a point or whether there's a phase to it?
There's a shape to it,
There's a shape to it, yeah. Okay. So, yeah, that's worth looking at. We have Venus at... it will be coming up to dichotomy on the 12th of January. That means it will appear to be 50% illuminated. But in actual fact, dichotomy will occur a bit later than that because of something called the Schroeder effect. But that's if you're looking with a large telescope. But it's worth looking around on the 12th of January just to see if you can see the phases about 50%.
Yeah. Okay, well, on the 31st of January, just to give you an idea how quickly things change with Venus, the phase will have decreased to 38%. That's because the planet's now on a part of its orbit which is bringing it closer to the Earth. So things appear to move faster with Venus when it's on this part of its orbit. And we will actually head towards inferior conjunction, which is on if I remember correctly, it's the 23rd of March. So I know we're in January at the moment as we're describing this. It doesn't take long before Venus sort of establishes itself in the evening sky.
And then falls towards the sun again.
And then it falls towards the sun and it disappears. You just get used to it and it's gone.
Yes.
What about Mars then? Mars in January is going to be pretty amazing.
It is.
It reaches opposition.
It does. And I should say, I have made a start on Mars in November. I've got a drawing of it. You've completely neglected it because you can't bear to go outside into the cold and be separated from your wine bottles. So.
That's not true. It's because I've had an awful bout of the flu, which has...
You have been quite unwell.
Which has rendered me completely unable to go outside, which is very frustrating. I did go out, actually, to have a look at Saturn because there was a transit of the shadow of Titan on Saturn, and I was really looking forward to that. And the seeing was probably as bad as it could possibly get, and Saturn was just a blob.
Yeah,
so it's not a good start.
No, it's the same here. But Mars has been becoming very good, and as Pete says, it comes to opposition actually on the 16th of January. And this is a great time to look at outer planets when they're at opposition because they're kind of due south at midnight and visible for most of the night. Now, one of the things interesting about Mars is not every opposition is equal. Mars can either come to opposition when it's furthest away from the sun, that's aphelion, an aphelic opposition, or it can come to opposition when it's very closer to the sun, at the closest point to the sun, called perihelion, and that's a perihelic opposition. And when this particular one is a aphelic opposition, so from the UK's point of view, Mars is going to be very, very high in the sky, but the apparent diameter isn't going to get much beyond 14, 15 arc seconds. So you kind of have to. There's pros and cons with each apparition for Mars.
I remember my first ever proper view of Mars through a largish telescope. It was a 222 millimeter homemade reflector. And I can remember the feeling of disappointment looking at it because it's a really difficult planet to observe. I mean, we talk about Mars and talk about its wonderful features, etc. But it is hard because you need to let your eye get used to the view. And if anybody has got a telescope for Christmas and they're looking at Mars and they're disappointed with what they're seeing, what you have to do is stick with it. You have to give it time. You have to let your eyes get used to the view, and eventually subtle detail starts to creep out. And as you become more used to what it is you're looking at, you will see more and more detail.
That's true. I'm just going to say, could it not be, Pete, that the telescope that you were using was your home-built one and maybe it was just a bit rubbish?
Yeah, you could say that, but actually it was extremely good. I got some great views of the planets. That's so cheeky.
But just putting it out there as an experimental option. But you are right, Mars is a very tricky subject. One of the things that really does help, I find with Mars, as you say, sticking with it, and this is where making a drawing is helpful, even if it's just a diagram. You don't have to make it a beautiful shaded drawing, but just a diagram. And then going on software, free software like WinDupos or any planetarium software, which will show you what features are visible, and trying to see if you can match up with what you've seen and what you've drawn with what's on the maps and what's in what should be on Mars. And by picking out more and more detail, you'll find that you'll get much better at it. But it is probably a couple of weeks' work, regular observing to get to that sort of stage.
And it's worth saying, don't do that the other way around. Don't look at the features first and then go out and try and draw them, because you will be biased as to what you can see. Yeah. But it is worth sticking with it, and seeing makes a huge difference with Mars.
It does.
Seeing is the term which describes how stable the atmosphere is. And one of the reasons why we get so excited when Mars gets really high up above the horizon, this opposition, it'll get up to about 63 degrees. It makes a huge difference because you're lifting the planet out of the turbulent, murky bit of atmosphere which occurs low down. So when that happens, you have a better chance of seeing it with stability. I can remember another apparition when I went out there, or another opposition period where I went out there and looked at Mars through my big C14, and the seeing was absolutely perfect. It was really still, very rare to get that in the UK, and it looked like Mars was a painting. Yeah. It was just so detailed. And when you get one of those nights, it just gives you faith to keep going.
It's Mars in good seeing when it's near opposition is at times overwhelming if you're going to try and draw it. Particularly when you've got mists and clouds there and you can see them changing over the course of an hour, and you see the rotation of things come into view, and you look down on the deserts, you think there's spacecraft, from Earth down there on the surface. It is quite an overwhelming experience. So every reason to persevere with Mars, I think.
Absolutely. And another overwhelming experience should be had with Jupiter as well, which is equally as high. It's about almost 60 degrees up Jupiter when it's due south. Yeah. And it's in a really good position at the moment, having passed opposition at the start of December 2024. So that's another one to look at through a telescope. Again, good seeing really helps. But it's got so much detail on it, Jupiter. It's just an absolute joy to look at.
It is. And we had recently, here in November, a phenomenon has just started on Jupiter, which is a southern equatorial belt disturbance, where you get this brilliant white plume appearing in the southern equatorial belt.
Oh, yeah.
And the Jupiter's very powerful winds distribute that material across the southern equatorial belt, can change its appearance. So this is... We don't know what's going to happen with it. We've been following it. Several of these events we've observed in the past, but it's been a little while since the last one. So, Jupiter's so dynamic, there's always something worth watching out for.
And if your view is boring, just wait a couple of hours because it rotates so quickly. New stuff comes into view very quickly. It's a 10-hour rotation, so if you get it early enough in the evening, you can watch the entire rotation of the planet in one night.
Yeah. The only one of the few planets in the solar system you can do that on.
Yeah. Okay, well, Saturn is dimmer than Jupiter. It's not getting up to such a great altitude. And in January, it is unable to reach its peak altitude under darkness because the evening twilight catches it early on, which is a bit of a shame. But it's worth mentioning that there's going to be an occultation of Saturn this month as well on the 4th of January. So we'll keep our eyes out for that and mention that a bit more in a moment.
Okay, and Uranus, well, it's relatively near Jupiter and well placed for observation, shines at magnitude plus 5.7 and reaches a peak altitude of 55 degrees due south. Currently in Aries and practically on the border with Taurus, so that's a good one to watch. Binoculars will show it, a telescope will reveal the disk and the greenish sort of cyan hue. Neptune, final planet, magnitude 7.9, is an evening object in Pisces. It's best seen at the start of January because it starts to lose altitude as darkness falls by the end of the month.
Yeah, it's not too far from Saturn actually at the moment, is it?
No.
Okay, well, let's move on to some of the special events we've got then. Well, on the 2nd of January at 21:45, Ganymede will be occulted by Jupiter. Io transits as the occultation concludes, which is a busy night on Jupiter. And 38 minutes after that point in time, Io's shadow will transit as well. Ganymede reappears from behind Jupiter's disk at 23:52 UT, and then Ganymede is eclipsed by Jupiter's shadow, so that you get a brief moment when the moon reappears, and then just a few minutes later at 00:19 UT on the 3rd of January, Ganymede slips into Jupiter's shadow until 02:50 UT. So that's actually quite an interesting thing to watch.
It's actually quite an interesting observation because Ganymede is the largest satellite in the solar system. In fact, it's larger than the planet Mercury. And under very good seeing conditions, when Jupiter's high in the skies, it will be this time, I think with high enough magnification, you can see Ganymede's a disk. You can see the shadow on it as it emerges. I've had a couple of observations of that. You do need a larger telescope. I think we're talking anything over 8 inches, 200 millimeters.
Well, if you have a planetary imaging setup, you can actually see the shape of Jupiter's disk it crosses Ganymede's. Jupiter's shadow as it crosses Ganymede's disk, and that's quite an amazing thing as well.
Okay, on the 3rd, the moon is setting early, which is good because sets the scene for the peak of the Quadrantid meteor shower, which will occur on the 3rd of January. Zenith hourly rate peak of 120 meteors per hour, so not too bad.
It's a good shower, actually, but a lot of people don't observe it because of the cold and the fact that it's that period where we've just had the holiday season and everybody's contemplating going back to work. I think nobody feels like going out, but it's a good one to go out and actually try and see.
Yeah, okay. On the 4th, although it may not feel like it, Earth is at its closest point to the Sun, and we are at perihelion on this day.
Also on the 4th, we have that lunar occultation of Saturn, when the planet will be occulted by a 25% lit waxing crescent moon. Now, occultation disappearance occurs at 17:18 UT, and reappearance will occur at 18:26 UT. Now, those times should be taken with a pinch of salt because the moon is close enough to us to exhibit parallax. So depending where you live in the UK, its position relative to Saturn will be slightly different. So the timings will be slightly different. So if you go out sort of 15, 20 minutes before those stated times, you shouldn't miss anything. If you want to find more information, it's covered in the magazine as ever.
Okay, on the 6th of January, the lunar X and V, clair obscur effects are both visible on the moon at that time. Around 1821 UT is probably the best time to catch it. And on the 7th, we have Titan's shadow transiting Saturn's globe. The event starts at 1624 UT, which is just after sunset, and finishes about 2132 UT under dark sky conditions. So there's plenty of time to try and catch it. And this isn't... We're getting a few of these phenomena now, but once the rings start to open up again after next year, this will become a rare phenomenon again.
It will. And again, this is what I've just recently tried to observe and had a great deal of difficulty because the seeing was poor. So if you don't see anything, then it may be down to the fact that the atmospheric seeing isn't great. So just keep at them and you'll get to see one. Also on the 7th, we have the Eyes of Clavius, the clair-obscur effect visible in that giant crater, which is visible near to midnight on the 7th. On the 9th, in the run-up to midnight again, the 81% lit moon can be seen approaching the Pleiades open cluster, and the moon continues to pass across some of the brighter cluster stars into the early hours of the 10th of January.
On the 13th, we have another opportunity to see a Ganymede shadow transit. Ganymede itself transits Jupiter from 1501 to 1726 UT. Its shadow will follow on behind Ganymede later on, 1829 to 21 UT.
On the 14th, the outer Galilean moon, Callisto, will appear 3 arcseconds from Jupiter's northern pole at 1720 UT. Now, you may wonder what's so special about that. Well, it's because Jupiter is approaching an equinox when it will appear sideways onto the Sun and to the Earth. So eventually, the outer Galilean moon, Callisto's orbit, which at the moment appears like a thin ellipse, will get even thinner, and the moon will begin to interact with the planet, which is quite an infrequent thing to observe.
I think I've only got a couple of drawings of a Callisto transit. They are quite rare, actually, as you say, Pete.
Yeah.
Okay. Right, so on the 23rd, Saturn's largest moon, Titan, will again cast its shadow on Saturn between 1528 and 2100 UT. Saturn sets around 2038 UT, so the Saturn will set from the UK before the event has finished, but still hopefully enough time to try and get it.
Okay, well, that's quite a lot of events there, and you can pick up other events in our calendar section in the Sky Guide in the magazine as well. Let's move on to the night sky now then, and Orion is probably the most prominent constellation. It's difficult to not look at Orion because it's a fantastic constellation to look at, and it's right in front of you when the sky gets dark. Orion is a great signpost in the sky. You follow the belt stars of Orion down and to the left, you arrive at Sirius, the dog star. That remains very prominent at this time of year as well. And when you look at it with the naked eye, you see it flickering red and blue as its light gets refracted, micro-refraction occurring as it passes through the thick layer of atmosphere low down. And you've also got atmospheric dispersion, which breaks the light into its component colours. So that's why you get those flashes of colour.
I think I will probably begin yet another fruitless attempt to try and see Sirius B. So Sirius, the star that Pete's just been talking about, is the primary A in the night sky, but it does have a white dwarf companion called Sirius B, which is much fainter. If Sirius B was far away from Sirius A, it's actually a fairly easy object, but because it's so close to Sirius A, which is very bright, seeing it is difficult. And I have, even with the 12-inch reflector I've been trying for a few years, I still haven't managed to pick it up. But this year, I'm going to make an occulting bar.
This year, you're going to do it. It's a good time to do it because the separation is close to maximum at the moment. I mean, it's not a faint star. It's mag plus 8.5.
Yeah.
The problem is the scale of separation is planetary level.
Yeah.
I don't mean it's measured in planets. I mean, if you look at the planets through a telescope, That's the sort of magnification you need to be able to see Sirius B.
Yeah.
The separation is such that it's on that scale. And I know in the past, a number of people have photographed Sirius and said, oh, I've got Sirius B. And they haven't. They've got a faintish star of similar magnitude, which is close to the pair. But you've got to go in really close.
So that's the other problem, is that there is a faint field star of about the same brightness of Sirius B, but further away. The only way to do it, I've actually got a chart, I can't remember where I downloaded it from now, I think it might have been NASA, that shows you the orbit of Sirius B around Sirius A and gives you the dates of when it will be in those orbits. So
I've put that in the magazine several times, so that may be where you've seen it.
I may be, and I'm not giving you...
I know you don't want to give me any credit.
You're very needy in this podcast, Pete, but I will... Okay, maybe it was your excellent diagram that I saw it, and that's the chart I'm referring to. But please do look at Pete's wonderful, magnificent charts and celebrate them. You feel happy now?
No, not really. So basically, if you can see Sirius, there's another wonderful thing that it guides you to, because if you go 4 degrees to the south of it in the sky, there's a beautiful open cluster which often gets overlooked for some reason,
yes.
Which is Messier 41, and it is a gorgeous thing to look for.
It is. I've actually only seen it a couple of times, but you're right, it does get often overlooked. I suppose it's because Sirius is... the Canis Major are a little low down. So particularly for me, I have to wait till the constellation is between the houses or at a height that I can see it. But it should be looked at. It is a lovely cluster.
Well, over to the east of Canis Major, which represents the Great Dog, which is the constellation which contains Sirius, of course, we have the constellation of Puppis, the poop deck, which is part of Argo Navis, the ship made famous by Jason and the Argonauts. But there are some great objects in there. We've got M46 and M47, which are two clusters which are actually quite close together. And you can see those with binoculars. But if you can use a telescope to look at M46, you might get a bit of surprise, because there's another object to be had here, NGC 2438, which is a small planetary nebula visible in the northern outskirts of the cluster. It's actually not part of the cluster itself. It lies in the foreground, but it's a nice thing to try and grab the pair of them together.
Yeah, I've never actually seen that, so that is certainly something worth taking a look at. Also, take a look north around midnight of the middle of January, and we can see a balancing act between the two famous circumpolar constellations, Cassiopeia and Ursa Major, perhaps better known as the W. Cassiopeia often appears as a W shape, and Ursa Major, the plough. And at this time of year, a line from Cassiopeia through the pole star and on to the plough is more or less horizontal. So that's actually quite, and it's quite impressive to see the plough climbing high in the northeast and the W of Cassiopeia sinking lower into the northwest at midnight. And the cold nights are off, and spring will be on its way.
They will indeed. Well, before we sign off this month, I think we'll just give a quick shout out as well to the Winter Triangle, which is one of my favourite patterns in the sky at the moment.
Is it, though? Is it one of your favourite patterns, or is it you just like talking about it?
I'm just trying to sell it. The Winter Triangle is an asterism formed by the star Sirius, which we've mentioned already, Betelgeuse, which is the bright orange star in the northeast corner of Orion, and Procyon, which, yes, if you find Sirius, you sort of go up and slightly off to the left, to the east a bit. And the only bright star in that part of the sky is Procyon. So those three together form the Winter Triangle, and the Winter Milky Way passes down through the Winter Triangle, occupied the most part of that area by the incredibly obscure constellation of Monoceros the Unicorn, which seems to have many deep sky objects in it, including the beautiful Rosette Nebula.
It does, but it is quite an obscure constellation. One thing I'll say about the Winter Triangle, though, it is genuinely only seen in winter, unlike its counterpart, the Summer Triangle, which
still around, isn't it? I think so. Yeah.
Most of the year.
Yeah.
So the Winter Triangle is definitely aptly named. And the other thing you notice is just how much fainter and less striking the winter Milky Way is compared to the summer one.
Yeah, because you're looking out from in the opposite direction to the core, so you're looking through a thinner layer of our galaxy, and it's not overly impressive. It runs down the eastern side of Orion, and even with long exposure photographs, it doesn't really stand out in the same way that the summer Milky Way stands out. But we've got a lot of things to look forward to here. Again, look in the magazine, look in the calendar section and the Big Three section, lots of observing targets to go for there. So if you have got a new telescope or binoculars for Christmas, plenty to look out for. Just need some clear skies. So wishing you all the best for 2025, and just remains for me to say thank you very much, Paul.
Thanks, Pete.